Question 2c. Find an expression for the coefficient of x squared in the expansion of 3x minus 4 over x all to the power of 8. Let's consider the expansion of a plus b all to the power of n. Now using the binomial theorem, that's n choose 0 times a to the power of n times b to the power of 0 plus n choose 1 times a to the power of n minus 1 times b to the power of 1 plus n choose 2 times a to the power of n minus 2 times b squared plus plus n choose n times a to the power of 0 times b to the power of n. So this is our first term, this will be our last term. Now the general term of a binomial expansion can be given by this formula, so that's TR, so the rth term, where r is 0, 1, 2, all the way to the nth term, is equal to n choose r times a to the power of n minus r times b to the power of r. Now we're interested in the term that contains x squared. So the sum of these two powers, so n minus r plus r, should equal 2. Now let's consider the terms in the particular binomial expansion. So that's 3x minus 4 over x. So we want x to the power of 8 minus r times x to the power of negative 1 all to the power of r to equal x squared. So we're not considering the 3 and the 4 at this point. All we're interested in is to determine the value of r first. Then we can determine the coefficient. So x to the power of 8 minus r times x to the power of negative 1 all to the power of r is equal to x squared. So expanding this bracket here, we have, and this bracket of course, so x to the power of 8 minus r times x to the power of negative r is equal to x squared. Now since the bases are all the same, we can just equate the indices. So 8 minus r, so that's 8 minus 2r is equal to 2, so the index here. And just solving that basic equation, we have r is equal to 3. So now that we have the value of r, that corresponds to the fourth term in fact, so since the first term corresponds to an r value of 0, we can then use this formula directly to compute the coefficient. So the coefficient of x squared in 3x minus 4 over x all to the power of 8, we're going to set r equals 3, and so the coefficient is 8 choose 3 times 3x all to the power of 8 minus 3, so of course that's 5, times negative 4 x to the negative 1, so sometimes I like to use negative indices, all to the power of 3. So we're only considering the coefficient of x squared. So we have 56, so that's 8 choose 3 is 56, multiplied by 3 to the power of 5, so that's 243, multiplied by negative 4 to the power of 3, and that's negative 64. So just be mindful of this negative there. It's going to alternate depending on whether this power here is even or odd. And that equals negative 870,912.